Hi guys, I hope you are fine. Me too, I'm fine. So it's another opportunity that God has given to us. And so we glorify Him and we thank Him because He is good. And so, guys, we come and now look at this question. And so I will read the question and then we continue. A machine produces rollers of mean weight 200 grams. The weights can be considered as being normally, that is the weight, being normally distributed. If in a bunch of 300 rows, 20 weigh more than 215, estimate the standard deviation of the weights. So guys, we are going to do that problem. So the first thing, I will use this normal curve here to do the question. I have drawn two curves here and I will be using them, guys, to draw this. The first one here, we have the normal. Let me say that this is the normal curve. Normal curve. We just write normal curve. Or this one is the standard. Standard normal curve. So guys, what I will do, I will use both of them in doing the question. The question again states that the mean, using the normal curve, the mean is supposed to be at the center at this point. And the mean is 200 grams. That is the mean. And then guys, we are saying in a bunch of 300 rows, 20 weigh more than 215. At this point, which is now 215, let's say this is 215, we have 20 here. We have 20. Let me write here, we have 20 rollers at that point, those that weigh more than 215. Then the question estimates the standard deviation of the weights. So now guys, what we come and see, we calculate, first of all, let's see the probability of those that are over 215. And the probability is now given by P of, this is over 215. So I can write 215 and I write like this. They are more than 215. Let me put the probability as, maybe I could put as X like that. So this one now is what we are looking for. And so guys, here we come and say it's now going to be 20 all over 300. The probability that they are more than 215. So this one gives us, if we use the calculator, we shall have, that is 20 divided by 300. That is 0.066. So we shall have 0.066. That is the probability at this point. But remember guys, now we want to come to the standard normal curve or the normal graph, the standard. So we shall get now the probability at this point, because for us to be able to get, first of all, the standardized form, that is of Z here, we need the probability because this at this point is 0, and this is what we now what we need. This is from the standard normal curve. And so because this one from here to this side is 0.5, because the whole of it is 1. This side is 0.5, this side is 0.5. So for me to get 0 to z, I'll now come and say from here to on the right side is 0.5, like that. I now subtract 0.066, like that. So for this one we are going to have, here we have 3 here, and this one now is going to be 4. So now guys, this is our area at this point. This is 0.433. So for us to get Z, we'll need to go to the tables and check the area for 0.433, what is our Z. So I now take the table and now check. Let me show you. Guys, this is now the table. As you can see, if I were to bring it closer, we have here our 0.433. This point is our 0.433. And so our Z now is supposed to be on this side. As you can see in this table, you check there at the top, you find this is our Z. So when you move along this column, is where now is now our Z along this column. And now our area is inside. Inside here is our area or our probability. Probability we have for that is 0.4332. So this is now going to be our Z. So the Z is 1.5. So here we shall have this Z as being now 1.5. That is our Z. So guys, we continue. After we get our Z, we know the equation for finding Z, and the equation for standardization is actually written like this. Z equals to X, that is our value, the value we had here, that is 215, minus now this value, which is now the mean, all over the standard deviation. So when we have these values, we have the mean and we have whatever we require here. This is now how we standardize our equation so that we can now go to the standard normal curve. And so this is the equation we use. So guys, because here guys, here we normally put like that, but we are not there, we are here now. So Z is going now to be, already Z we have identified is 1.5. So what we remain to identify is actually the standard deviation. X we had 215. Now minus the mean, which is 200. So I write there 200. And now what we do not know is the standard deviation. So this one is going to be now 215 minus 200 is 15. Standard deviation is there, and then we have 1.5. So guys, we shall have standard deviation being equal to 15 divided by 1.5. So this one gives us, this one now is going to give us, once again, standard deviation now is going to be 15 divided by 1.5 is supposed to be 10 grams. And so guys, that is our solution.